Hello, fourth grade. Welcome back to another episode of Math Math. We are in Unit 5 talking about fractions. Last week, we focused on unit fractions, how they work, how they operate, with numerators, denominators, how we add them, how we subtract them. We talked a little bit about improper, proper fractions, mixed fractions. We kind of just hit like some of the basics. This week, we are focusing on equivalence. What fractions are equal? How do you know? How do you tell? So we'll just jump right in. But yeah, I'm excited. But if you have any questions or are still kind of just on the fence about unit fractions in general, please feel free to go back to last week's video before you jump into this one, okay? But let's get started. These are the essential questions and sentence stems for the week. Pause the video to read over them, but they are also available on your Math Blend page. Here is the vocabulary for the week. Feel free to pause the video to read over the words and see if there are any you may not know. Okay, let's define what equivalent fractions means, and then we'll jump into it, what it looks like visually. But the definition is equivalent fractions are two fractions that are equivalent or equal if and only if they are both represented by the same point on a number line or represent the same portion of a same whole size for an area model. So I would have two separate fractions, right? Let's X and Y, and then A and B. I'm just putting letters for now as placeholders. I could tell if the two fractions were the same if on a number line, if they both were on number lines, fell on the same spot, or if I drew a picture, had the same amount shaded, okay? Visually, if you just looked at it quickly, without looking at how many numbers or parts, if it was the same amount shaded, they would be equal. We'll get into what that looks like visually in a second, but I just want to make sure that you know an equivalent fraction is comparing two different fractions that might have two different numbers, yet visually on a number line or in a area model have the same portion. So same portion shaded in an area model, same point on a number line, that would be equal fractions. If they somehow fall off of that a little bit or show a little bit more shaded or a little bit further on the number line, then they are not equal. But let me show you a couple of these examples visually, okay? Okay, something that's important to note is fractions that are equal to 1, literally just 1, and fractions that are equal to half. And an easy way is just to like list them all out. So all of my fractions equal to 1, you can start as small as 1 over 1, 2 over 2, 3 over 3, 4 over 4, 5 over 5. If it has the same number in the numerator as the denominator, it's equal to 1. So it could be 12 over 12, you name it, 30 over 30. However, whatever number you want to put, it's going to be equal to 1, right? So 10 over 10, you can keep going. Same number, top and bottom, equal to 1, always, okay? Remember that, that's just like a rule. When talking about what's equal to half, the number on the top is always going to be half of what the number is on the bottom. So 1 is half of 2, right? 2 is half of 4. 3 is half of 6. You can keep going. 4 is half of 8. Okay. 5 is half of 10. 6 is half of 12. Keep going. That any of these fractions are equal to 1/2 because the number on the top is half of what's on the bottom. Okay. And again, you can keep going. You can do 16 is half of 32. Let's see, 20 is half of 40. Any of these are half. You can keep going forever and ever as long as the number on top is half of the number on the bottom. These are all equivalent fractions. All of these are equal to 1. All of these are equal to 1/2. Doesn't matter how you put it as long as they are half of the number on the bottom. So hopefully this helps and makes sense. This is just a rule I need you to know so that on the next part, what I'm about to show you, it'll help you a lot, okay? So feel free to keep practicing in your math journal. Keep writing what would be equal to 1. Keep trying to figure out what would be equal to half. That's a good practice. Okay, let's start with area models. I have 5 different circles here, and I'm going to show you how these 3 can be the same and all equal fractions, and how these 2, how we can make a different example together. So at the top, you see 1/2 equals 2/4 equals 4/8. I know that last week you would look at that and say, how, what? I don't understand. And so I'm going to shade it in so you can see how they're actually equal, even though they show different numbers, okay? So let's shade in what the fraction is telling us. There's 2 parts, which is the denominator. One of them is shaded. Okay, so I'm going to shade in 1/2, okay? There are 4 parts, but it's telling me to shade in 2 of them. So 1, 2. Do you see so far how this is the same? They're equivalent because on an area model, visually, if I quickly look at it, half of that circle is shaded. Half of this one is shaded, but this one was split into 4 parts. 2/4 equals 1/2 because it's still half of the circle, okay? This one has 8 parts, the denominator, but 4 of them are shaded. So 1, 2, 3, 4. Do you see how that also equals this? Because only half of the circle is shaded. 4 out of 8 pieces, right, of a pizza was eaten. 2 slices out of a pizza that was 4 slices big was eaten. 1/2 of a pizza, someone ate a whole half altogether, of a pizza, right? So these visually all look the same. They all end up at the halfway mark. It's half the circle, right? Even though we represented it in different fractions. Let's do another example. Down here I have a circle divided up into 4 parts and another one divided up into 8 parts. What's another example that was not here that we could do? Okay, and you can always do this in your journal, draw your own circles and kind of practice it out and see if it looks the same visually and count how many pieces, write up your fractions. For the sake of this one, I am going to only shade in 1 part. So what would be my fraction here? I have 1 out of 4. So this is 1/4, this is 1/4, this is 1/4, this is 1/4. So 1/4 equals, how could I represent the same? If I shade in 1 here, does that look the same? Not yet. If I shade in another one, does that now look the same? Yeah, I have a piece of this shaded in, right? But this is going to be a different fraction when I represent it. How many parts are there? 8. So each one is going to be out of 8, right? 1/8, 1/8, 1/8, 1/8, 1/8. Do I say it's equal to 1/8 plus 1/8? I could do that. But then going back to what we learned last week, if I'm going to add this up, what would be my actual equation? This would actually be 2/8. 2/8 is equal to 1/4 because it looks the same, or the same was shaded, or the same portion was shaded on a similar whole, right? Area model. So 1/4 equals 2/8. 1/2 equals 2/4 equals 4/8. Hopefully this makes sense, but you're just looking at it visually, how much is actually shaded, and then you can actually divide it up into more parts. So if I wanted to do out of 16 pieces, I would only shade in 8/16 to show still half of that circle. You could keep going. Same thing here. So hopefully this makes sense, but let me show you area models with sets, and then I'll show you on number lines as well, okay? Okay, this is still an area model, right? It's a picture, we're drawing it out, but it's with sets. And so I want you to just kind of pay attention first, but second, I want you to keep an open mind to this, okay? How many circles, these are 2 different examples, how many circles do I have shaded out of how many, right? So the amount shaded is going to be my numerator, the number on top. The total amount of circles, just in general without shaded or not, is going to be my denominator. So how many circles do I have total? I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so at the bottom, I have total of 8. How many do I have shaded? 2, 4, 6. Okay, so I have 6 eighths represented, right? Okay, how else could I draw this out to equal the same? How else could you group these? I'll take a second. Just take a guess. There's no wrong answer. I just want you to kind of imagine how you would represent that differently. How many pairs are there? Like groups of 2, not pairs of fruit. How many pairs are there? So I have 1 pair, 2 pair, 3 pair, 4 pairs. That would be my denominator. I have 4 pairs. How many pairs are shaded in? 1, 2, 3 out of 4 are shaded. 3/4 equal 6/8. Does that make sense? It's just a different way to look at it. It still says the same because we're talking about the pairs. It's still this. Later we'll get into how you compare these, but this represents the same because using the same set or area model, we were able to look at it in 2 different ways. And that's kind of what I'm getting at for this week, is just how can you see the same picture and split it up and make up a different number for it to mean the exact same thing. So let's look at this one. How many circles do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 circles total. How many of the 15 are shaded in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 15 are shaded. What's another way I can look at this? How many groups of 3 are there? 1, 2, 3, 4, 5. I have 5 groups of 3. How many of these groups are totally shaded? 1, 2, 3, 4. 4 out of 5 groups are shaded. 12/15 equals 4/5. There's not going to be too much of this, but again, I just wanted to share with you in case it does come up, or in case maybe it takes you a bit to think in that way. That's okay. That's normal. Don't get frustrated. This just takes practice, and you have to kind of really look at it and be open to a different perspective. Okay. But let me show you on number lines. Okay, number lines. I'm going to show you 2 different examples. We'll take it one at a time. And I'll show you in 2 different colors so you don't get confused. But, all right. I have 0 to 1 on both number lines. Let's look at the first one. I split this up into fourths. Into thirds, sorry. So if I were to go a little bit at a time, I would have, let's see, I have 1/3, 2 thirds, and then to get to 1 equals 3/3, right? 3 out of 3. So this is one way to look at it from 0 to 1. 1/3, 2/3, 3/3, right? So this area from here to here is 1/3. This area from here to here is 1/3 and 1/3. So all of this equals 1/3, right? I added the 1/3 and 1/3 up, I get 2/3. I added up 1/3 plus 1/3 plus 1/3, I get 3/3, which equals 1. Okay, so far that makes sense. Are we good? Okay, now I also have these lines in between that I could look at it differently. How many do I have? 1, 2, 3, 4, 5, 6. So it's talking out of 6. So this is 1/6. This is 2/6. This is 3/6. This is 4/6. This is 5/6. And this one over here is 6 out of 6. What do we notice? Do we notice that some of them are equal to each other, right? For example, let me get another color marker here. Let's see, maybe the purple one. 2/6 equals 1/3. 4/6 equals 2/3. 6/6 equals 3/3. Do you see how We used area models and we had different numbers, but because they were shaded the same, they were equivalent, they were equal. On a number line, because they land on the same point on the number line, they are equal. 2 6 equals 1/3, right? Now, 1/3 does not equal 1 6. Well, why? It's like right above it. I was just saying that space from here to here is 1/3. This space from here to here is 1 6. This space from here to here is 1 6, 1 6, 1 6, 1 6, 1 6. It takes 2 of the 1 6 to make up a third. So that's where we get these numbers from. It makes 2 of these, 1, 2, 2 6, to make up 1/3. That is why we're saying that they're equal when you're counting these up, right? So 1 6 plus 1 6 plus 1 6 plus 1 6 is 4 6, because we added up 4 of them 4 times, equals 1/3 plus 1/3, 2/3. Okay, hopefully this makes sense. If not, please rewind and watch that again. Let's look at this one. How many lines do I have? I can look at the big lines first. Let's see, 1, 2, 3, 4. So this one is out of fourths, which is where I got that from the other one. Anyway, so 1/4. From here to here is 1/4. From here to here is 1/4. So I'm going to add those up. That would be 2/4, right? 2/4, 3/4, bing, and 4/4. Right? So each of these equals 1/4. And like we learned last week, you add those up. You only add the numbers at the top, the numerator. Some of you were still adding the denominators. Don't do that. So we have out of fourths. That's what that represents, right? So let's break it down a different way. I see more lines in between, a different way to look from 0 to 1. Let's add up those and see how much would be on our denominator. So 1, 2, 3, 4, 5, 6, 7, 8. Now we're talking out of eighths. So from here to here is 1/8. I'm adding these up. This would be 2/8. This would be 3/8. 4/8, 5/8, 6/8, 7/8, 8/8. So which ones equal each other? Yep. 2/8 is the same as 1/4. 4/8 is the same as 2/4. 6/8 is the same as 3/4. 8/8 is the same as 4/4. Ta-da! Right? Why? Again, because 1/8 plus 1/8 is 2/8 is the same as 1/4. I'm making 2 jumps here. That's why that number's there, but I'm making 1 jump here, right? So that's where those numbers come from. Same thing, made 4 jumps here. So 4/8, made 2 jumps here, 2/4. Same thing, right? You can add these up all the way, and that's where those numbers are coming from. It's how many jumps you took, how many times you had to add up that unit fraction to get to that point on the number line. Does 3/8 equal 1/4? No. 1/4 is here, 3/8 is here. It's different points on the number line. It does not equal each other, okay? So you can kind of mix and match with any of that. So does 6/8 equal 2/4? No, 2/4 is here, 6/8 is here. They're different points on the number line. So you want it to be on the exact same point on the number line. On a question, if it were to ask you, the easiest thing you could do is draw an area model or draw out a number line and make all of your points to see if it lands in the same spot. That's an easy way to do that, and that's where we're starting. Hopefully this makes sense, but let's do a couple of practice problems, okay? Okay, what if you're like, Ms. Diaz, I want to know how to find an equal fraction. How could I do that? This is how. To find equal fractions, you're going to get just any fraction you can think of. To find someone or a fraction that's similar, you multiply, listen carefully, you multiply this fraction by a fraction that is equal to 1. Okay, it doesn't matter what it is. So, for example, if I have 3/4 shaded here, I have 3/4 shaded here. You can see how it looks visually, right? There's only one piece that's missing that we don't have. If I want to find something that is equal, I am going to multiply this fraction by a number or a fraction that is equal to 1 whole. So all of the fractions we listed out in before this clip, you can go back and pick one of those, but I'm going to choose for now 2/2. 2/2 equals 1 whole, okay? Right? We all agree? This means that I'm going to multiply 3 times 2. This goes back to your multiplication chart. You can use that. 3 times 2 gives me what? 6. 4 times 2 gives me what? 8. Okay, let's represent this on the circle. Let's see if it's actually the same. So I'm going to make 8s. That's 4ths. That's 6. That's 8s. And I'm going to now shade in 6 out of 8. So let's see. 1, 2, 3, 4, 5, 6. Does that give me the same? Yeah. What? Magic. Yeah, no, seriously. So 3/4, 1, 2, 3, leaves 1/4 out. Here I multiplied it by a whole fraction that represents a whole number as 1. So 3 times 2, 6, 4 times 2, 8. It gave me the same thing. I have 2 8s that are not colored in. So you could even say 2 8s is equal to 1/4 over here, which it is if you put that on a number line or whatever. But visually, you can see how we did this, right? So I did this by multiplying by 2. Let's try to find this fraction equivalent to this one in a different way. Let's multiply it by something else. What would that be? Another fraction that equals a whole. It can be anything. 3 over 3, 4 over 4. For now, let's say 3 over 3. So I am going to multiply 3/4 times 3 over 3. This also equals 1 whole, right? So I would do 3 times 3 to give me the top number. 3 times 3 is 9, okay? 4 times 3 is the denominator, right? The bottom number is 12. Is 9/12 equal to 6/8 and equal to 3/4? Well, let's see. I have 4ths, 6, 8s. Oh boy, how do I do this? I have 8, 9, 10, 11, 12. I need to separate. That wouldn't be equal. Let me see. 12 is kind of tricky to draw in a circle. And then I would have here, right? 2, 3, 4, 5, 6. Be there. That's 8, 9, 10, 11, 12. That kind of works. My drawing's a little off, but let's see. 9 out of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can kind of tell my triangles are not all equal, but it still leaves this part open, right? So this part, this is kind of needs to be better drawn, but that part. So yes, it's still equal. 3/4 equals 6/8, which equals 9/12. If I wanted to write it all together, equals 6/8 equals 9/12. If you were to just look at this on a paper, you'd be like, does it? You could draw a area model. You could draw 3 circles and try to shade them in like this. Or you can draw your number line from 0 to 1, and you can split up the spaces by 4ths. You can split up the spaces by 8ths. You can split up the spaces by 12 and count and see if they land on the same spot, right? That's another way that you could do this. So to find equal fractions, multiply it by a whole number. That's really the big idea here, is multiply it by a whole number, a fraction that represents 1. So 2 over 2, 3 over 3, 4 over 4, 5 over 5, 12 over 12, it doesn't matter, you would still find the equal fraction. Even though it says 3/4 and you had a big number, if you multiplied this times 12, and those are big numbers, that's still equal to 3/4. So take as many practice with any of these fractions. Actually, I can give you a couple practice problems after this. Let me erase my board, okay? So I'm giving you 3 random fractions, 3/4, 5/15, 2/8. Multiply it by a fraction that represents a whole number, such as 1. So 4/4, 3/3, 7/7. You can replace those by any other number if you feel more comfortable with that. But try doing these in your math journal. Pause the video, write these down, see if you can multiply. I'll do the first one with you. 3 times 4. So 3 times 4 is 12. 4 times 4 is 16. 12/16 equals the same as 3/4. Try doing the next two. See if you can multiply just across. You're multiplying this across, this across. You're multiplying these numbers across to give you the answers on the other side. So this would equal the number on top, this would equal the number on the bottom. Same thing here, same thing here. This fraction, whatever you come out with, is going to equal the same as the fraction from before. And you can draw them out just to verify. You can always check your answers by drawing an area model or by putting them on a number line. But this is just good practice, and you'll be seeing more of this week. Hopefully this makes sense. Okay, I'm gonna make an equal fractions chart just to see, for you to see how easy it can be to find like many fractions that are equal quickly. What is equal to 1/3? If I multiply both the numerator and the denominator by 2, 1 times 2 is 2, 2 times 3 is 6. 2 6 equals 1/3. If I multiply these two numbers by 3, 3 over 9. If I multiply these two numbers by 4, 4 over 12. Multiply it by 5, 5 over 15. All of these fractions equal the same. They all equal 1/3. Equal, 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 right? I just multiplied by fractions that all equal 1. So here I multiplied 2 over 2, multiplied the 3 over 3, 4 over 4, and so on, right? Let's do the same thing with these bottom fractions. 1/5, if I multiply both times 2, that would be times 2 times 2, that equals 2/10. If I multiply this fraction 3 times 3, so that would be 3/15. If I multiplied it by 4s, that would be 4/20. If I multiplied both by 5, that would be 5/25. And you can see how they're skip counting, right? 3, 6, 9, 12, 15. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 10, 15, 20, 25. There's different ways to look at the same thing. Here, same thing. Times 2, right? Both at the top and at the bottom. Times 3, both at the top and at the bottom. Oops. Whoa. 3/30, right? Both at the top. 4/40, 5/50. You can see how there's patterns. This is with fraction that I just started with 1. You could do the same if I had, let's say, a 2 at the top, then you would, right? Same thing. So 2 times 2, 4, 2 times 3, 2 times 3, 6, why am I blanking? 2 times 4, 8, 2 times 5, 10, right? It just, however you want to put it together, that's totally fine. But you can just make a chart and just make sure that you're multiplying the same number at the top and the same number on the bottom that has to represent a whole, right? So 2 over 2, 3 over 3, 4 over 4. And you can just multiply and make a chart this way. You can know that everything in this row, they all equal each other. Same thing here in this row, right? So that's just another way to figure out equal fractions. Hopefully this helps, but let me know in Zoom if you have any questions or concerns, or if you're not understanding how this is working. That's okay. Okay, last thing before I let you go. This also works dividing the same fraction that represents a whole. If I want to make this into a smaller fraction, smaller numbers, you don't have to multiply every time. You can also divide by a same number. So let's say I wanted to divide a whole number being, I don't know, 3 over 3. That represents a whole. What is 3 divided by 3? That gives me 1, right? 12 divided by 3 gives me fourths. So 1/4 equals 3/12. Okay, let's try another one. I want to divide this by 5 over 5. That equals 1 whole, right? 5 divided by 5 equals 1. 15 divided by 5 equals 3. 1/3 equals 5/15. Okay, right? Let's say I want to divide this by fourths, 4/4. I want to make this smaller. 12 divided by 4, 3. 20 divided by 4, 5. 3/5 equals 12/20. You can always check your answer by going the opposite way. So I wanted to make this bigger, 3/5 times 4/4. I can go backwards, right? So 12/20. Yes, that makes sense. So you can always just jump back and forth between the two. That's really just kind of what I wanted to get at, that yes, you can multiply to make equal fractions. You can go always backwards by dividing by the same number. So that chart that we made by times 2, times 3, times 4, times 5, you can divide it by 4, divide it by 5, right? Divide it by 3, divide it by 2, and make all your way all the way back. So it works both ways. Thank you all for watching another episode of Math. Hopefully this made sense. If it doesn't, please feel free to go back and watch again, or ask me any questions or concerns that you have during our Zoom meetings. But feel free to jump into the play pause that's right after this video. Check out your assignments in Dreambox, and yeah, we'll work on it and practice together. I love y'all and have a great week. Bye.